Good morning, dear students. My name is Ferhan Mazher, and today is 4th of December 2021. And right now, I am with the 11th cabinet class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve an MCQ paper, and we have selected May June 2009 paper, and we will solve this MCQ paper. This paper has 40 questions, and you have 1 hour to solve this paper. So let's start this paper, May June 2009, Physics 5054, paper 1. So let's go to the paper. So here we go. So question number 1 coming up on your screen. It says, which instrument is most easily used to measure the internal diameter of a pipe? The internal diameter of the pipe, we can use vernier caliper, because the vernier caliper has internal jaws, which can easily, with the help of those internal jaws, you can measure the internal diameter of a pipe. So I think that D is the right choice. D is the right choice. And let's check. Question number 1, D is the right answer. Okay. So question number 2 coming up on your screen, and it says, which statement about scalars and vectors is correct? A scalar has direction but no size. That's wrong. A scalar has the scalar has size but no direction. A vector has direction but no size. A vector has size but no direction. The question is, which statement about scalars and vectors is correct? I think B is the right choice. A scalar has size but no direction. Now the next question. Let's check first the marking scheme. What the marking scheme says. B is the right answer. So I think B is the right answer. A free fall parachutist falls at a constant speed. He then opens his parachute and continues to fall to earth at a lower constant speed. Which diagram shows how the distance fallen by the parachutist varies with the time? You see here we have 4 distance time graphs. All these graphs are distance time graphs. So here the gradient of this graph is equals to the speed. So look at this graph. Here the graph is flat, so the gradient is 0. Here the graph is flat, the gradient is 0, means speed is 0. So again here the gradient is constant, it's flat, so the gradient is 0. These cannot be the answers because there is a certain speed of the parachutist. So in the B part, you can see that here it has a certain gradient, a constant gradient, and then here we have a certain gradient, but this gradient is lower than this gradient. So here the speed is higher, a constant speed but higher. Here constant speed but lower speed. So I think B looks the best option to me. And this D, here we have a constant speed, but here the speed becomes 0, which is wrong. Because it was at a certain speed, a constant speed, and that speed was higher. And then it has again a constant speed, but that speed was lower. So in the first portion, the gradient should be larger, and then the gradient should be smaller. but the gradient is not zero. It means the graph is not horizontal. So I think B is the best option. Question number 3, B is the best option, sir. Question number 3, B looks the best option. Question number 3, I think B is the best option. Yeah. Question number 3, B is the right option. So let's go to the next question. And the next question coming up on your screen is question number, let me get it. Question number 4. It says that the graph shows the speed of a runner during a race. So it's a speed time graph. What is the distance traveled? What is the distance traveled by the runner during the race? So the distance traveled by the runner is a speed time graph. So I can find the distance traveled by the runner if I find the area under the speed time graph, and I can find the area under the speed time graph if I divide this into different portions. For example, I put a line here, so this will be a triangle. Then I put a line here, so this will be a rectangle. And when I put a line here, so this portion will be a trapezium. So if I find the area 1, area 2, and the area 3, and then add them up, that will be the total area under the speed time graph, and that will be equals to the distance traveled. So let me show you. I have done this on a paper. So first of all, the problem is coming with the camera. So here you can see that distance time, that speed time graph, and this first portion is a triangle. The base is 4 and the height is 5. So I can find the area 1 by 2 base into height 1 by 2 into 4 into 5, and that will be 10 meters. And then I have this area 2, which is a rectangle. This length is the 10, and this height is 5. So I will 10 multiply 5, and that will be 50. Then this area, which is a trapezium, its height is 2. This parallel side is 5, and this parallel side is 10. You know, the area of the trapezium is 1 by 2 into height into sum of parallel sides. So you will have 1 by 2 into 5 into 5 plus 10. So 2 and 2 will be cancelled. So 5 plus 10, that's 15 meters. So I will add up area 1, area 2, area 3, and that will give me the total distance. So 10 plus 50 plus 15, and that will be 75 meters. So I think the area under the graph is 75 meters. So let's check. Do we have that answer? 75 meters. I think C is the right answer. Question number 4, C looks the right answer to me. Question number 4, C is the right answer. Question number 4, C is the right answer. Okay. A person just sports a mass of 20 kg suspended from a rope. What is the resultant force acting on the mass? So because this is just suspended, neither is moving upward nor downward, it's just suspended. So the resultant force will be 0. Because the body is neither moving upward nor going downward, it means that the body is in balance. So the upward downward forces will cancel out each other. The resultant will be 0. So I think because it's not moving, so I think that the option will be A, 0 Newton. The resultant force will be 0. So let's check. Question number 5, A is the right choice. So question number 6 is coming up on your screen, and it says a particle P is moving in a horizontal circle about O. P moves at constant speed V. Which statement is true? A force of constant magnitude is acting in the same direction as the V. The force is acting here, and but its direction is not along the V. It is always towards the center of that circle. A force of constant magnitude is acting towards, oh yes, that can be the answer. A force P, varies. It says the force P on P, the force on P varies in size as it moves around the circle. And the fourth part is there is no resultant force acting on the P. When you are moving in a circle, a resultant force acts on you and it is always directed towards the center of that circle. So I think B looks the best option to me. B looks the right option to me. So question number 6, B is the right answer. Question number 6, B is the right answer. A measuring cylinder contains 118 centimeter cube of water. When a small object is fully immersed in the water, the reading goes up to 132 centimeter cube. The object has a mass 42 gram. What is the density of the object? Now you see, we can find the volume of that object. That is V1, V2 minus V1. And here the V1 is 118 centimeter cube. The V2 is 132 centimeter cube. We know the mass of the object, so very easily I can find the density of that object. And that will be 42 divided by 42 gram is the mass divided by the volume. Let's check. I will show you my work. I've done this. So V1 is 118 centimeter cube, V2 is 132 centimeter cube, M is 42 grams, and the volume of the object will be V2 minus V1, and that will be 132 minus 118, and that will be 14 centimeter cube. Now the density is mass divided by volume. The mass is 42 and the volume is 14. So 42 by 14, and that will be 3 grams per centimeter cube in the answer. They have written 42 by 14, 42 by 14, 42 by 14, 42 by 14. I think B looks the best option. B looks the best option, sir. Let's check question number 7. Question number 7, B looks the best option. Two blocks are placed on a beam which balances on a pivot as its center. The weight of the beam is negligible. He says, which diagram shows the forces acting on the beam? The length of each arrow represents the size of the force. So you see that they are equally spaced, equally spaced. They are at equidistant from this pivot. So, and it's balanced, so it means that the forces acting downward and the forces acting in the upward direction, they are equal. So if these are the two forces, then the upward force at the pivot should be equal in length to the sum of these two. So here that is not happening. Here, if I add this and this, and plus this will be not balanced. These two, this here the weight and the here the weight, they should be equal to each other. So these arrows which are acting downward, they should be equal in size. And the force here on the pivot, that should be equal to the sum of these two. So B looks the best option, sir. B looks the best option to me. B looks like the best option because if I add this and this, it will be equal to this force which is acting on the pivot. And here this is not in balance, this force is larger. Here this is not in balance because this force is larger. So I think B is the best option, sir. Question number 8, B is the right option. Question number 8, B is the right options. The graph shows the extension of a piece of copper wire as the load on it is increased. So on it's an extension load graph. On the y-axis, the extension is represented. What does the graph shows? It means up to this point, the extension and the load, they are directly proportional to each other. But after that point, the load, if you increase the load, the extension in the wire will be not proportional to the load. It will be quite large extension because the graph has curved upward. So it means that after this point, the extension has become very easy. If you increase a little load, the extension will be larger. So what does the graph shows? At a certain load, the wire becomes easier to extend. Yes, that's true. At a certain load, the wire becomes harder to extend. No. The load and extension are directly proportional for any load. No, they are directly proportional, but after a certain load, they are no more directly proportional to each other. The load and extension are inversely proportional for any load. That is not true. So I think A is the right answer. Question number 9, A is the right option. Question number 9, A is the right option. A builder leaves two identical heavy stone tiles resting on soft earth. One is vertical and the other is horizontal. After a few hours, the vertical tile has started to sink into the soft earth, but the horizontal one has not. Which row correctly compares the forces and the pressure that tiles exert on the earth? You see, they both are exerting their weight on the ground. So the forces are same because they both are identical. So they both have the same, I think, both have the same weight. So the force which is acting downward, that is their weight. In both the cases, that weight is same. And the pressure exerted by each tile is different. The reason is because their contact area with the ground is different. For example, in this tile, the contact area is very large. So for the same weight, it will be less. It has less pressure. Here, the contact area with the ground is very small. So its pressure will be larger. So both these tiles, they have the same force, which is their weight, and the pressure they are experiencing is different. So in one, the pressure is larger because the contact area is smaller, and in the other, the pressure is smaller because the contact area is very large. So I think the forces acting are same. That's their weight, which is acting on the sand, soft earth, and the pressure exerted by both these is different because their contact area with the ground is different. So the forces same and the pressures different. So I think D is the choice. Question number 10, you can see that C is the right answer. A water manometer. A water manometer is connected to a gas supply. One end of the manometer is open to the atmosphere. Which statement about the pressure of the gas supply is true? Here you can see that here we have the gas supply. Here this end is open to the atmosphere. Here we have some mercury in it. And the level of the mercury is different. Level of the mercury is different in both the limbs. So, on the gas side, the level is lower, and on the atmosphere side, the level of the mercury is higher. So that means that the pressure of the gas is larger. It has pushed the mercury downward, or water. We have water here, not mercury here. So it has pushed the water downward, and on this atmosphere side, the level of the water is higher. So it means that the gas pressure is larger than the atmosphere pressure. And how much it is larger? Whatever is the difference between the levels of the water or the liquid in both the limbs of the manometer. So I think that the pressure of the gas is 8 centimeter of water larger than the atmosphere pressure. So the pressure is 8 centimeter of water, 8 centimeter of water above atmospheric pressure. So I think D looks the best of the two. D is the right option, sir. Let's check. Question number 11, D is the right option. Which process in the sun produces energy? In the sun, the nuclear fusion is taking place. Nuclear fusion means that the smaller nuclei, they come close to each other and they make a larger nucleus. That's called nuclear fusion. And that is happening on the sun and other stars. So which process in the sun produces energy? That is not nuclear fusion. Nuclear fusion. Question number 12, C part. Question number 12, C is the right answer. The crane lifts a load of 1000 Newton through a vertical height of 3 meters in 10 seconds. The input power to the crane is 500 joules per second. What is the efficiency of the crane? So you see, I can find the efficiency of the crane. The process is very simple. It is that the process is very simple, we can find out the output power, and power is work done divided by time. The work done will be weighed into the vertical height divided by time. So once you know the work done, the output power, I mean, the useful output power, and you divide it with the input power, and that will give you efficiency. Total output power divided by the input power, and that will give you the efficiency. So let me show you. Load is 1000 Newton, the height is 3 meters, and the time taken is 10 seconds. So the input power is also given, that's 500 joule per second. So the useful output power is equals to load multiplied vertical height divided by time. So it will be 1000 and into 3 divided by 10. So that will be 300 joules per second. So the efficiency will be the useful output power divided by input power. So it will be 300 divided by 500. So it will be 3 by 5. So that will be 0.6. So let's check. So I think C is the right answer. C is the right answer. And it says the C is the right answer. So let's check. Let's check question number 13. C is the right answer. Question number 13, C is the right answer, sir. Question number 12. So, okay, so we are going to the next question, and the next question is question number 14. And it says the question number 14, it says the diagram. The diagrams shows 4 identical cans with their outside surface painted either dull black or polished silver. Each can contains the same volume of water initially at 80 degrees centigrade. After five uh, after 5 minutes in a cool room, which can contain the coolest water? Okay, so the coolest water will be, I think, where the radiation has been stopped. Sorry, uh, the water was hot, so they are losing heat. The coolest water will be where the radiation emitted is largest. So I think this open ones, they will be the coolest, and between them, the coolest one will be whose color is dull black, because the dull black will be a very good emitter of the infrared radiation. So the coolest one will be, I think, A, because it is its lid is not there, and its lid is not there, and its color is dull black. So the dull black is a very good radiator. So I think A is the choice. Question number 14. A is the right choice. What makes a liquid in glass thermometer sensitive to a small change of temperature? What makes a liquid in glass thermometer sensitive to a small change of temperature? A bulb with a thin glass wall? No. A shiny liquid in its pore? No. A stem with a thick glass walls? No. A very narrow bore? That is the thing which affects the sensitivity of a thermometer. The capillary in which the mercury travels, that should be very small. The more it is small, the more sensitive the thermometer will become. So I think D is the right choice. Question number 18. I think question number 18. D is the right choice. Yeah. A substance that is originally a solid is strongly for some time. A substance that is originally a solid is heated strongly for some time. At one stage, the energy given to the substance is used as latent heat of vaporization. At this stage, what change does the energy causes? So it's saying at one stage, the energy given to the substance is used as latent heat of vaporization at this stage. But what changes does the energy causes? It breaks the bond holding the molecules together. Molecules escape from the liquid. Yeah, it breaks the bonds holding the molecules together. The solid becomes liquid, and it makes the molecules move faster, but there is still a strong attraction between them. And it makes the molecules move faster, and so the temperature rises. So a substance that is originally a solid is heated strongly for some time. At one stage, the energy given to the substance is used to as a latent heat of vaporization. What changes the energy? What change causes the energy? What change does the energy cause? It breaks the bond holding the molecules together. At one stage, the energy given to the substance is used as latent heat of vaporization. So when the latent heat of vaporization is involved, it means that the liquid is converting into gas. So the options are: it breaks the bond holding the molecules together, molecules escape from the liquid. That can be the answer. It breaks the bond holding the molecules together, the solid becomes liquid. No, that is not the answer. It makes the molecules move faster, but there is still a strong attraction between them. That's wrong. It makes the molecules move faster, so the temperature rise. That is also wrong, because during the state change, the temperature do not rise. And it says it breaks the bond holding the molecules together. Molecules escape from the liquid. I think this is the answer. I think this is the answer. A is the choice. Question number 16, A is the choice. Yes, A is the right choice. What happens when a metal bar is heated? The distance between the molecules increases, making the bar longer. Yes, that's true. The molecules get larger, making the bar longer. That's wrong. The molecules size do not change. The molecules vibrate more quickly, making the bar denser. No, that's not right. The speed of the molecules increases, making the bar thinner. And no, that's not true, because the speed of molecules will increase because you are heating it, but the bar will not become thinner. So the distance between the molecules increases, making the bar longer. That looks the best option to me. You heated a metal bar, so it will expand. So it means the distance between the molecules has increased. Okay, so I think 17A is the right choice. Question number 17, A is the right choice. So the next question: a fixed mass of gas at constant temperature is compressed to reduce its volume. How do the molecules of gas now strike the walls of the container? A fixed mass of gas at constant temperature, this is important, is compressed to reduce its volume. How do the molecules of the gas now, because the temperature is constant, so the velocity will not change, it will remain the same. Less often than before with the higher velocity? No, velocity will not change. Less often than before with the same velocity? That's also wrong, because you have compressed the gas, so the pressure will increase. More often than before with the higher velocity, the higher velocity thing is wrong. More often than before with the same velocity. Yes, that is the right answer. The because you have reduced the volume, the pressure will increase, the temperature is constant. Due to the temperature constant, the velocity will be the same because the pressure will increase. So the molecules will collide with the walls of the container more often. So I think D is the right answer. Question number 18, D is the right answer. Yes, question number 18, D is the right answer. Which diagram correctly represents water waves traveling from deep water to shallow water? So the water waves are traveling from the deep water into the shallow water. In the deep water, the speed is higher, the wavelength is also higher. And in the shallow water, the speed will be less. And so the wavelength will also decrease. So the wavelength should decrease. So B and the D cannot be the answers because when the water waves enter into shallow water, their speed decreases. So when their speed decreases, the wavelength will also decrease. Whatever happens with the speed, same thing happens with the wavelength. So the wavelength should decrease. So B and the D, they cannot be the answers because you can see that the wavefronts have a larger distance between them as compared to these wavefronts, sorry. So here the wavelength has increased, that's wrong. So out of these two, one of them is the answer. So because when the water wave will enter into shallow water, its speed will decrease. So it should bend towards the normal. It should bend towards the normal. So if you draw normal here, if I draw normal here, this one has bended towards the normal. If I draw normal here, it has bended away from the normal. I think A is the right choice. Question number 19. A looks the right answer. Question number 19, A is the right answer, sir. So that was question number 19. And now we have question number 20. Which characteristic describes an image formed by a plane mirror? The characteristics of the image which is formed in the plane mirror is that the image is virtual, the image is upright, the image is laterally inverted. So A is real and inverted, that's wrong. Virtual and upright, that's true. Real and large, that's wrong. In the mirror, you don't get no. So real and larger than the object, no. Virtual and smaller than the object, no. Virtual and upright, that looks the best option. Question number 20, B option. Yeah, that our answer is right. The diagram shows 4 rays of light from a lamp below the surface of some water. What is the critical angle of light for light in water? You see, the critical angle is that angle of incidence in the dense medium for which the angle of refraction in the rare medium is of 90 degrees. That angle of incidence in the dense medium for which the angle of refraction in the rare medium is of 90 degrees. So that angle of incidence is called critical angle. So you can see that this angle B, the B angle here, you can see this is the angle of incidence in the dense medium, and you can see that the angle of refraction in the rare medium is of 90 degrees. So this angle of incidence is known as critical angle. So the B is the right option. Question number 21. B is the right option. Question number 21 and B is the right option, sir. Question number 21, B is the right option, sir. When the white light is dispersed by a prism compared with the blue light, the red light is, as compared to the blue light, the red light, it, when you have that RIG-BIV, that is the, let me show you. Okay. So that code word is R O RIG-BIV. G BIV. RIG-BIV means that RIG-BIV, red, orange, yellow, green, blue. So the red, this is the order of the spectrum, the colors of the spectrum, RIG-BIV. So red is above the blue, so it means the red slows down less and it's refracted less. The blue will be below the red color. So it means that the red, compared with the blue light, the red light is slows down less and refracted less. So I think A is the choice. Question number 22. Let's check. Question number 22. Question number 22, A is the right option, sir. An ultrasonic tape measure is used to find the distance to a wall. It sends out an ultrasonic pulse and times how long it takes for the reflected pulse to return from the wall. The ultrasound has a frequency, a wavelength, and a speed. Which pair of values is needed to find the distance to the wall? Uh, you know, uh, Frequency and the wavelength, no, frequency and the time taken for the pulse to return. Yeah. Speed and time taken for the pulse to return. And yes, that's true. And the wavelength and the time taken for the pulse to return. Which pair of values is needed to find the distance? Find the distance to the wall. We need the speed, and I need the time taken for the pulse to return. So I think C looks the best option. Question number 23, let's check. Question number 23, C is the right option, sir. Question number 23, C is the right option. An iron nail can be magnetized using a coil. How can the nail be demagnetized? If you put here alternating current and then you withdraw this nail, automatically this nail will lose its magnetism. It will be demagnetized. So he says, how can the nail be demagnetized, leaving the apparatus switched on for a long time? For demagnetization, remember, we always use alternating current. For demagnetization, we always use alternating current. So leave the apparatus switched on for a long time. No, removing the nail from the coil while using an alternating current supply. Yes, that's the best, I think. That is how you demagnetize something. Using a coil with fewer turns, no. Using more turns, that's also wrong. So how can the nail be demagnetized? For demagnetization, we use alternating current. So that was question number 24. B is the right option. So let's check. Question number 24, B is the right option, sir. A negatively charged balloon is brought towards a wall. Which statement explains what happens? Negative charges on the balloon attract the negative charges on the wall. That's wrong. They will repel each other. Negative charges on the balloon have no effect on the charges in the wall. That is right. That's wrong. Negative charges of the balloon repel the negative charges in the wall. And that can be true. Negative charges on the balloon repel the positive charges in the wall. That's wrong. So I think C is the best option. C looks the best option to me. Question number 25, let's check. Yeah, C is the right option. When a filament lamp is switched on, there is a current in the lamp. As the temperature of the filament rises, its resistance changes. Which pair of graphs show how the resistance R of a filament and the current I vary with the time after the lamp is switched on? So, here we have 4 options, and you can see that if you look at the graphs. So in this question, you see we have there are 2 kinds of graph in each option, and in each option there's a graph between the resistance and the temperature. For example, here you can see resistance and temperature, and then you have the graph between the current and the temperature. So when he says the temperature rises, the resistance also rises. So the graph should go upward. So it means that C and D, they cannot be the answer. The resistance increases with the increase in the temperature. So the graph should go upward. And the temperature and the current, the second graph is temperature. And the current, as the resistance will go up, the current coming from the battery will decrease. As the current will go up, as the temperature will go up, the resistance will increase, so the current passing through that will decrease. So I think here this and this, they are the correct options. So I think B is the right option. Question number 26, B looks the best option to me. Question number 26, B is the right answer. Okay. 1 volt can also be written as, the famous definition of the volt is energy divided by time. So it will be, energy will be joules, and the 1 unit of that is V is equal to work done divided by charge. Work done divided by charge. Volt, that's the definition of the volt. Work done divided by charge. Work done divided by charge. So work done will be joules and charge will be coulomb. So I think D is the right option. Question number 27. Yeah, question number 27, D is the right option. A student has a chain of 20 lamps. These are, a student has a chain of 20 lamps. These are wired in series and connected to the mains. One lamp blows up, blows, and all the others goes out. The student wants to find the faulty lamp and replace it. How should the student begin? So it says anywhere, because the current was the same in each lamp. At the live end of the chain, because the current has greatest there, because the current was greatest there. At the middle of the earth, because the current has greater greatest there because the current was greatest there. At the neutral end of the chain because the current has least there, was least there. Because the current was least there. So the student wants to find the faulty lamp and replace. Where should the student begins? I think A is the right option, sir. Anywhere because the current was the same in each lamp. Question number 28, I think A is right. Question number 28, A is the right option. An electric iron is marked 240 volt and 2500 watt. 4 fuses are available with the values of 5 ampere, 10 ampere, 13 ampere, and 30 ampere. Which fuse should be used? Okay, so you have the power, you have the this 240 volt, and P is equals to IV. P is equals to IV. A very famous formula. P is equals to IV. So I can find out the value of the I. Let me show you my work. Okay. Now the voltage is 240 volt and the power is 2500 watt. P is equals to IV, so I will be equals to P divided by V. And 2500 divided by 240, and the answer will be 10.42. The answer will be 10.42 ampere. So that was question number 29, 10.42. Because the current is 10.42 ampere, so the fuse should be more than this. So the fuse can be, I think, 30 ampere. Question number 29. C is the right option, sir. A plug is wrongly wired as shown. It is connected to an old vacuum cleaner which has a metal case. What is the effect of using the plug wired in this way? The fuse in the plug glows. The metal case is live. Yes, you can see that you have colored that green and yellow. That means earth wire, and this brown color means the live wire, and the blue color means the neutral wire. So you can see that these two are together. So you have basically connected the live and the earth wire together. So when you will do this, what will happen? The casing, because the earth wire is connected with the casing of any device, and when you have connected the live and the and that earth wire together, so due to this the whole body of that appliance, they will become live. So what is the effect of using the plug wired in this way? The fuse in the plug glows, maybe. The metal case is live. Yes, the metal case has become live. That's question number 30. Let's check. B is the right option. Question 30, B is the right option. So let's check. So we are on question number 30. Here we go. An AC supply is connected to a wire stretched between the poles of a magnet. Which way will the wire move? Which way the wire will move? So here's alternating current. So you can use the left hand rule. You can see that I have stretched my finger. This is left hand rule. This is F, this is M, this is C. FMC, FMC, remember this code. And so the magnetic field is from the north to south, and if the current will come towards me, then the thumb will point in the upward direction. So you can see I stretched my left hand. You can see that from north to south, these are magnetic field lines, and 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 suppose when the current will move towards me, my thumb points upward. So it means it will go upward, then it will come downward. So it will go up and down. So I think so. Which way will the wire move? Up and down. According to the left-hand rule, I just found the direction. Question number 31, C is the choice. Yeah. The DC motor consists of a coil of many turns rotating in a fixed magnetic field. The coil is connected to a DC supplied through a split ring commutator. Some changes are made one at a time. The DC supply is reversed. The coil is turned before switching on so that the P starts on the right and the Q on the left. The poles of the magnet are reversed. Okay. The turn on the coil are increased in number. How many of these changes make the coil rotate in the opposite direction? How many of these changes make the coil rotate in the opposite direction? So this is basically a motor. This is basically a motor. So the question is, how many of these changes make the coil rotate in the opposite direction? The direction of the rotation should change. So DC supply is reversed. Yes, that's true. And the coil is turned before switching on so that no, that's not right. The poles of the magnet are reversed. Yes, that can also be the reason. And the turns on the coil increased in number. But by increasing number of in turns, you cannot, the turns on the coil are increased in number. No, that cannot be the reason, because we want to change the direction of rotation. So I think the DC supply is reversed. That's one. And the poles of the magnet are reversed. That's second. So I think B is the best option. Question number 32, B is the right option. Question number 32, B looks the best option to me. Question number 32, B is the right option, sir. The diagram shows an AC generator connected to a resistor. Some changes are made one at a time. The speed of the device drive is changed. The strength of the magnet is changed. The number of turns in the coil is changed. The value of the resistor is changed. Some changes are made one at a time. The diagram shows an AC generator connected to a resistor. Some changes are made one at a time. How many of these alter the value of the EMF in the coil? Okay, EMF. Yes, you can change the speed. It will increase the EMF. Some magnetic charge changed. Yes. The number of turns in the coil is changed. Yes, that's also true. The value of the resistor is changed. No. So how many of these alter the value of the EMF generated in the coil? Speed, yes. Strength of the magnets, yes. The number of turns in the coil, that is also true. The value of the resistance change, I don't know that. So I think 3. C is the best option. Question number 33, C is the right option. Yeah. Further, we have to decrease it. A simple AC generator produces a voltage that varies with the time as shown. So this is alternating current, and it's taking 4 seconds to complete. So in 4 seconds, there's only single wave. So which graph shows how the voltage varies with the time when the generator rotates at twice the original speed? So here you can see that the mean value is only 1 square above. So when the speed of rotation is at twice, so the voltage produced will also become twice. So I think in 2 in 4 there is 1 wave. There should be more waves. Plus their amplitude should increase. There should be more waves. The generator rotates at twice the original speed. So the EMF will double and more waves will show on the display. Originally there was 1 wave, one complete wave. Now there will be at least 2. And the amplitude of the vibration will also increase. I think D is the right answer. The amplitude has become double in the same place. Now there are 2 waves shown. So that's true. So I think D is the right option, sir. Question number 34, I think 34. D is the right answer. Question number 34. D is the right answer. What is electric energy usually transmitted at? Why is electric energy transmitted usually at a high voltage? You know, the reason is very simple. We transmit the electric energy at a very high voltage, and by doing so, the current will reduce. And this reduces the power loss in the transmission lines. As little energy as possible is wasted in the transmission cables, no. And the current in the transmission cable is as large as possible, no. The resistance of the transmission cable is as small as possible, no. The transmission system does not require transformation. So this says, why is electric energy usually transmitted at high voltage? As little energy as possible is wasted in the transmission cables. The current in the transmission cables is as large as possible. No, the resistance of the transmission cables is as small as possible. And the transition system does not require transformation. We make the voltage very high by using the step-up transformer, and the reason is that so that the current becomes smaller and the energy loss or the power loss in the transmission lines becomes less. So I think as little energy as possible is wasted in the transmission line. That is the reason why we step up the transformer, why we step up the voltage, the current with the help of the transformer before sending the current in the transmission line, so that the power loss or the energy loss in the transmission lines is reduced. So let's check question number 35. I think A is the choice. Question number 35. A is the right choice, sir. A lamp is connected in series with the light-dependent resistor, LDR, and a battery. The barrier shields the LDR from the lamp. When low-intensity light falls on the LDR, the lamp glows dimly. If the light intensity on the LDR increases, what happens with the lamp? It will get brighter. The reason is because when the light will fall on the LDR, its resistance will become less. So the resistance of this whole circuit will also become smaller when the light will fall on it, because LDR is light dependent resistors, and their resistance will decrease when the light will fall on them. So in the bright, the resistance will decrease. So the current coming from the battery, that will increase. So, and it will take less voltage. This will take less voltage, and here the voltage will become available for the lamp will become larger. The current value will increase. So the power used by this lamp will also increase. So it will become brighter. It gets brighter, I think. So I think A is the choice. Question number 36. A is the right option. So you can see this. A is the right option. Okay. The circuit diagram shows a variable resistor R connected in parallel to the lower half of a potential divider. The resistance of the R increases. What happens to the 2 voltmeter readings? So as you will increase this R, the resistance here, the total resistance of these two will increase. So the R2 value will increase. So the V2 will increase and the V1 will become smaller. The question is, the resistance of the R increases. What happens to the 2 voltmeter readings? Because when this will increase, the whole this resistance will increase, and so this V2 will take the larger voltage. When it will take larger voltage, the V1 will take uh, V1 reading will decrease. So the V1 reading will decrease and the V2 reading will increase. So I think B is the right option. Question number 37. Let's check. Question number 37, B is the right option, sir. Question number 37, B is the right option. Read the question. Okay. A radioactive source emits alpha particles, beta particles, and gamma rays. A Geiger-Müller tube, which we call GM tube, and counter detect the emissions which pass through the thin sheet of paper and a strong magnetic field. What is detected by the GM tube? Here are some charged particles which are coming like this. The charged particles are coming like this. I am using left hand rule. The magnetic field is from north to south. The magnetic field is from north to south. My thumb is pointing downward. So if the charged particles are positive, they will go downward according to the left-hand rule. But the charged particles are bended upward. So it means that they are not positively charged. They are negatively charged. So it means that there is beta particles only. So there are beta particles only. I think question number 38, D. D looks the best option. Question number 38. D is the right option, sir. The count rate from a radioactive source falls from 400 to 50 in 3 minutes. What is the half-life? Okay, from 400 to 50. So in one half-life from 400 to 200, and from the next half-life, they will go from 200 to 100. And in the next half-life, they will go from 100 to 50. So let's check. Let me show you my work. So you can see that from 400 it will go to 200 after one half-life. Another half-life will pass. So from 200 to 100, another half-life will pass, and it will go from 100 to 50. So basically there are 3 half-lives. So 3 into half-life will be equal to 3 minutes, because the time passed by is 3 minutes. And so the one half-life will be 3 divided by 3, and that will be 1 minute. So the half-life will be, I think, 1 minute. Do we have that option there? Yeah, we have this option. So question number 30, question number 39, I think 1 minute is the answer. That's the half-life. Hopefully you understand how we have done that. Okay, so we have question next coming up on your screen, and it says that what are the numbers of neutrons, protons, and electrons in a neutral atom of uranium-92 235? So the number of protons will be this number 92. The number of neutrons will be 235 minus 92, and the electrons will be equals to 92. Let me show you my work. So uranium 292 235, number of protons is 92. The number of neutrons will be 235 minus 92, and that will be 143. And the electrons will be equals to the protons, so 92. So let's check 92, 143, and 92 and 92. Number of neutrons will be 143, number of protons will be 92, number of electrons will be also 92. So I think C is the right option, sir. I think question number 40, C is the right option. So let's check. Yeah, question number 40, C is the right option, sir. So, my dear students, today we have done May, June. Today we have done May, June 2009, Physics 5054, paper 1. I hope that this video will help you to understand these concepts and improve your physics concept. If you find this video helpful, don't forget to subscribe to my YouTube channel, and don't forget to share the link of this video on the Facebook and on the Instagram. So if you can benefit from it, your friends and class fellows can also benefit from it. So thank you very much, everyone, and have a good day. And it was a big pleasure for me to teach you online. So thank you very much once again. Have a good day. God bless you all.